Now let me introduce you to today's speakers. We have Craig Polk, Product Development Manager at Vitex. Before joining Vitex, Craig was at Bell Labs and Nokia, where he led innovation across several industry sectors, including healthcare, education, and environmental science. Craig is a graduate of Stevens Institute of Technology and Purdue University. He's passionate about developing products that save lives, bring joy, and inspire the future. We also have Rich Witte, Sales Manager at Vitex. Rich graduated from West Point in 1987. After his service in the Army, Rich went on a career selling capital equipment to the semiconductor industry. Rich has many years of engineering and sales experience and joined Vitex last year. And now over to Craig.
Thank you, Priya. So today we're going to be talking about USB, what's changed, what's kind of new, where we see things going in the future. So right now I'm just bringing up my screen sharing, so hopefully everyone will be able to see it shortly. So we're just going to go through a couple of these topics, and if you have any questions at any point, please go ahead and use the chat as Priya mentioned. So a lot of us know what USB is. It's been around for quite a long time, starting out in '96. And it was really a very nice and easy and simple interface to connect computers with a lot of different peripherals. It has a lot of advantages over prior interfaces that were used that when you had to connect directly to hardware, to motherboards. So there's a nice plug, different connectors we'll get into in a little bit. It is self-configuring. A lot of the operating systems, and especially now with Windows and Linux, all support a plug-and-play option to it. And it provided the ability to have power over a common cabled interface and not needing additional power supplies. So I know a lot of credit is given to Intel in the '90s for coming up with this. But there's actually quite a few different companies that were involved, such as IBM and Compaq, Microsoft, NEC, DEC, and Nortel, which were big players in coming up with this standard. And of course, over the last 25, 26 years, it's really changed quite a bit. So starting out in the '90s with version 1, we had devices primarily such as human interface devices such as a mouse or a keyboard. And we had two main connector types, that being A and B. And as we move into the future in a couple of years, we started seeing different connector types come out, such as the Mini A and the Mini B. And this would allow for different types of devices to kind of get into the mix more, and it would allow for a lot more simultaneous connections. I believe the standard adds up to 127 devices could be connected. And so as we continue our version upgrades through 2 and moving towards 3, we start seeing the mini and the micro connector becoming more popular. And we start seeing enhancements in the type of power that's being able to carry over some of these micro B and micro AB connectors. And as we moved into more recent decade, we see USB 3 coming out, and we see the data rates also continuing to increase, moving from a 5 gig to a 10 gig. And one of the very visual changes that came about in the standard was the use of blue for the cables and the connectors. And then as we moved into version 3.1, and we'll also see in version 3.2, there was a new connector type known as the USB-C, which is very dominant right now. And we'll talk about why that is. So one of the important things to kind of keep note of is that some of these versions, as they change with standards, they also just change from a naming and a rebranding perspective. especially as we move into 3.1 and 3.2. We start hearing things about Gen 1, Gen 2, Gen 1 by 1, Gen 2 by 2. So it could be a little confusing, and we're definitely here to help you out with all of your understanding for your cable and your connector needs. But some of the important highlights to note is that the version 3 and version 3.1, they moved into a USB version 3.2 Gen 1. And then the Gen 1 one came out with, the Gen 2 version came out for USB version 3.1. That's known now as USB 3.2 Gen 2. And so what was originally kind of defined and coined as USB version 3.2 is now known as Gen 2.2. And so some of the advantages that come along with this is we really see that the speed has increased as we move into this. There's much more standardization around the connector that's used. As we move into Gen 3.2, we see only the type C being used, which is very common in like video equipment, wireless cameras, IoT devices, cell phones, other mobile devices will use this type C connector and really only use this type C. So now the 3.2 is really the dominant version that's used in devices. And we can see that it does give a lot of advantages. The primary one is the rate that we're able to get. We're able to get up to 20 gig. There was some backwards compatibility added in since some of the previous versions had issues working with slower devices, especially some of the initial human interfaces like keyboards, mice, or slower rate USB hubs. 3.2 feature also increases the amount of power that we're able to carry over the cable. So you'll see 100-watt applications. And some of this will be known as the quick charge or the light charge or speed charge that you'll see on some USB devices, especially in IoT and wireless devices. And it's USB kind of, has gotten a lot more into the audio video realm, where we'll see display and audio signals now being carried over USB cables, especially in areas such as laptops, where you can see these USB-C to multiple output connections, where you can have an audio, you can have, say, a display port, as well as a USB 3 or USB 2 connection, all coming from a small kind of single input to multi-output device now that comes with a lot of laptops. So that's a trend that's coming out. But, one of the things to really keep in mind is, and we've seen this with some other standards in the computing area, is that just because something says that it complies with the standard, and especially through a lot of these rebrandings, doesn't really mean you're going to get all the features. They're really going to need to check what the specs are, or talk to the people that are providing the solution for you, so you can understand what you're really getting. So this brings us into why do we really need USB connection over fiber, since a lot of the applications are really close or known for being close. We've talked about human interacting devices, printers, cameras. And so we do see that there's three primary kind of options that we have. We have our basic copper connection, and then when we move into fiber, we have a pure fiber and a hybrid fiber connection. And one of the things that's kind of really good from a product perspective, when you talk about the fiber and copper hybrid solution, it brings in some of the features of the best from the both options, right? So we get this kind of known entity where we have a cable. We're used to a single cable of connecting things, and it kind of looks like what historically a USB setup or solution would look like, but it also provides additional power, since we do have copper mixed in with the fiber connections. And so this brings us to, well, what's our disadvantage of our kind of copper solutions, and it's really on distance. So USB is pretty limited on how far you're able to run. So if you're trying to connect something through a building or a campus, you're not going to really be able to make your solution with just using copper. So you're going to need to go onto fiber where your distances are able to be increased, and we can see this distance limits of the copper that are here. It's really on a couple meters at best that we're able to get, and especially with the new version that has come out like in 2019, and new additions are going to come out in the future. Distance is also a big limit. So you really need to consider fiber if this is a solution that you want to think about. So where is this going in the future? So the USB 4, just as it's the prior one that came, is focusing on the USB-C connectors, and it's adding in even more power delivery options. So being able to power devices is going to be a big benefit through this version. And we're finally seeing some compatibility with Intel's Thunderbolt 3.0, which is going to be very helpful for devices that Intel manufactures and comes out that uses those protocols. And we are going to see further improvements in the resource handling, especially for tunneling that's being offered for video and PCI Express. So that's going to bring a more smooth and better experience to the end user. And it's also going to help with things just that are using historical past versions of 2.0 or 3.0, that you will actually see a slight improvement on the speeds for using hubs and other interconnected devices.
Thanks, Craig. I appreciate all of your expert tutelage. I'm very impressed, or from an old guy's perspective, it's interesting to me how USB is somewhat transitioning from peripherals to more use in video over fiber. So that's kind of fascinating, once again, for an old guy like me. So I noticed we have a picture of the USB AOC extender, and then underneath, Vitex has also recently released an all-in-one fiber extender, also known as our KVM extender, and go a little bit more into that on the next slide. This is kind of nice. I just wanted to show you a little bit about what the connections look like. Of course, you've got your HDMI, and this one you could get DisplayPort if you'd like. One of the nice things about these, this product is that you have transmit and receive video over fiber to establish a secure connection. You connect devices and peripheries and transmit from your transmit to your receive up to 1,000 feet. So that's really quite special. They're all customizable, so you can build your own. Once again, the video is either DisplayPort or HDMI, and now once again, the USB 3.2, taking more of that video application. And then you've got Ethernet if you need any internet capabilities, infrared for remotes. And then, of course, you've got your audio remote channel, which is good for audio for HDMI. If you would do me a favor and go to the next slide, please. We have a number of growing applications for video over fiber. We've been in the business 18 plus years, and we see a lot of interactions with our military customers, mostly for simulation systems, both flight simulations and also other types of training. We have a lot of applications for boardrooms or conference rooms with big board displays. We also do a lot of things with, the old school concerts or athletic games where we have large event displays. And then one of our biggest application niches right now is in the medical equipment manufacturers, anything that's going into a hospital, anything around large magnets needs to have a low EMI certification. So our DisplayPort extenders are low EMI, in particular the pure fiber ones, not the hybrid ones. We can customize applications for our customers. For instance, instead of just extenders, we're working right now with a large customer for embedded display, HDMI or V-by-1 interfaces where we're actually attaching right to their boards. So if you have a customizable requirement, please feel free to contact us. And I think my contact information or our contact information is on this slide. I thank you very much. And I know that it's close to 4th of July, but does anybody have any questions?
Yeah, we got one related to compatibility. Just about what's the backward compatible options with the USB, and that's a really good question and point to bring up, because especially around USB 3.0, there was an issue where past devices weren't able to communicate, and so it's very important that the solution, either it being a pure fiber or a hybrid solution, is on a version that's compatible with these older devices. And I know at Vitex, and maybe Rich will add a little more to this. We have sampling options that we can do to help kind of verify and vet out your solution. So I don't know, Rich, if you wanted to say a little bit more about that.
Sure. I mean, we have inventory in our samples. Typically, in a lot of these applications, EDID becomes a concern for some people. Some of the displays, which are, I guess, not up to current standards, typically have some issues with working well with the graphics cards, and so we like to test out some of our extenders to make sure it's compatible with your requirements. We also can go back in and rewrite the codes on the EEPROM to be able to customize. If you have a large population of monitors which aren't behaving properly, we can go in and customize the EDID to make sure that they're all compatible. And those are sitting on the shelf, and it's a nice way to do business. You get to try it before you buy it. So please keep us in mind. Thanks for the shameless plug, Craig. Appreciate it.
Yeah, and I think we got time for one more. So there's a question, I guess, just about use case, just because we brought up the use of video and other extenders where you would have USB possibly without video. And so I guess from what we're seeing is we do see the both types of use cases where you have either just a need for video transfer or sometimes video and USB. So we did show some of those different options, because if you think about it from your kind of command center, you're going to have your displays and you're going to be able to give feedback on whatever type of devices that you have, or so you may have, for example, a mouse and a keyboard, and it could be needed in different locations of the campus or office area where you are. So there are different options for how you bring those signals back and forth, and using fiber to get across that span is a huge advantage in that area. So if you do have a solution where you're looking for something like that, I would say definitely reach out to us on the information that's there, and we can go through the different options with you.
Thanks again, Craig. Any other questions? Well, thank you for joining us today. We appreciate it, and have a wonderful and prosperous 4th of July weekend. Thank you very much.
All right. Thank you, everyone.